Spatial behavior in ants. First of all, we need to understand what's a spatial behavior. Spatial behavior is the behavior or spatial memory as a behavior that humans and animals use to guide through space while traveling through a particular environment. Brain creates maps of the area around and possible obstacles, which are later used to guide new routes through the same environment. The main type of clues vertebrates use, and some invertebrates as well, are visual landmarks, distance, directions, which differ based on the organism's complexity. The more complex is the organisms, the more complex visual clues they will start using. The main experiments conducted in this about the spatial memory were in the labs using mice. The hippocampus, which changes in size depending on the spatial demands placed on animals by their ecology, is the primary brain area involved in processing spatial information in vertebrates specifically, even though the invertebrates have it too, but it might differ. The hippocampus. There are many examples of spatial memory around us that we don't notice very often. For instance, we usually take the same route if we observe how we get from the kitchen to the bedroom. It is one of many representations of spatial memory in humans. Another interesting one is that people avoid hitting obstacles while sleepwalking in a familiar environment, of course. Spatial behavior is widely used in various aspects of business. For example, real estate agents consider buyers' spatial behaviors to decide what home or what neighborhood they will likely consider based on the schools, on the kindergartens, or certain things they tend to do every day. The same things are used by marketing agents. They use these techniques to organize the stores or to organize the marketing campaigns. One of many problems that animals face is how to find food, find their way back to home, and avoid predators along the way. The answer to all of those questions is spatial learning. It allows such simple actions as finding food for ants, avoiding traps for mice, to complex animals like us humans, or complex behaviors as migration through thousands of miles. Here are some fascinating facts about ants that we might not know. For example, ants can carry 50 times of their own body weight, or both the mass of all people on Earth and the mass of all ants combined would be equal. Another interesting thing is that ants are social insects and they live in colonies. And an average ant, the garden black ant that we see every day, it lives longer than an average dog does. They tend to live in the nests, and the largest nest that was found was 3,700 miles wide. Ants have the record for the fastest movement in the animal kingdom. The aptly named species of trap-jaw ants can close their jaw as fast as 140 miles per hour, which is used to kill its prey or injure predators. Ants are an excellent example of spatial learning, spatial memorizing. And have you ever observed an ant that walks a straight line, one after another, or how they avoid an obstacle all the same way? This type of pattern is due to ants' ability to have spatial memory as social insect. Ants have many different expressions of spatial memory. Here is some very interesting video as an example of spatial learning. This is from TED's educational videos. I'd like you to watch a few minutes of it.
One of the most impressive collective capabilities of an ant colony is to thoroughly and efficiently explore large areas without any predetermined plan. Most species of ants have little or no sense of sight and can only smell things in their vicinity. Combined with their lack of high-level coordination, this would seem to make them terrible explorers. But there is an amazingly simple way that ants maximize their searching efficiency by changing their movement patterns based on individual interactions. When two ants meet, they sense each other by touching antennae. If there are many ants in a small area, this will happen more often, causing them to respond by moving in more convoluted, random paths in order to search more thoroughly. But in a larger area with less ants, where such meetings happen less often, they can walk in straight lines to cover more ground. While exploring their environment in this way, an ant may come across any number of things, from threats or enemies to alternate nesting sites. One of the most impressive collective capabilities of an ant colony.
Okay. An example of spatial behavior in ants is how they find their way back to the nest. They travel a long distance to get food or to get some other supplies, we can say, to build their nest. And they have to somehow get back to their nest. The experiment showed that ants use objects around them, the position of the sun, and they count the number of steps they took to find their way back to the nest. During the experiment, the source of the light was changed, and the ants weren't able to get back to the nest, which proves that they used the position of the sun at the specific moment to find their way back. A different experiment used the length of the ants' feet so they changed the length, they shortened it, and they weren't able to get to the nest. And while they lengthened the length of their feet, they went past the nest. When they used 3 different types of ants, once with the long feet, once with the short feet, and once with the normal feet, they were able to successfully get to the nest. This proves they have a special connection between individuals. They send each other signals and they help each other to get back to the nest. Another study was performed using velvet ants that are cursorial parasitoids. Cursorial means that they run a long distances, they don't stay in one place for a long time. Parasitoids means that they are a parasite during a special time of their life, and once they are adults, they kill the host organism and start living freely. They're not they don't nest, they don't tend to come back to the nest. However, during the experiment, it was demonstrated that the ants have visual learning ability. They can memorize visual clues. During 7 days of the experiment, they were able to learn how to get back to the nest. And once the position of the nest was changed, they were still able to get back to it. This proves that they have a spatial learning ability. They memorize the obstacles around them, around to the goal that we're headed to. One thing is to navigate in the open air where there is a lot of light, even though they don't have a strong vision, or some of them, they don't have vision at all. But a different thing is to navigate in the dark labyrinth-like nest, which is where every ant has their own space that they need to find once they get back to the nest. They spend a lot of time outside the nest, finding food, finding resources, but they also spend a lot of time working inside the nest and protecting the queen. Ants use 3 main routes in navigating within the nest. First are self-reference cues, where the ants memorize multiple target locations and orientate towards them with no requirement for any visual or olfactory cues. Second are social generated chemical clues that are placed at decision points located away from the destination and mark the route towards it. Third are the navigations assisted by global gravitational clues. there are different ways to show how ants combine this different information sources and how individuals can adjust the weight attributed to conflicting cues in a way that allows them to adopt new routes while abandoning unrewarding ones. Once an ant found a food source, they leave a trace of pheromones behind them, which gives a clue to other ants that there is a food source somewhere nearby. So they follow the same route, and once they come back, they leave a trace as well. And as it goes, the trace becomes stronger and stronger, and once there is no more food left, the trace starts to fade away, and no more ants go back to that specific route. This fast individual learning process leads to global, stable improvement in the collective performance of these colonies. Here are some works I did if you want to follow up with the information that I give during this presentation. Thank you very much.